Now this is the condensed form of a logarithm, and we want to expand the logarithm. So this is question number 1. So let's see how we can expand this logarithm. So since square root of y is still the same thing as y raised to the power of 1 over 2, and we can see that we have the third root of z raised to the power of 4, which can also be written as z raised to the power of 4 over 3. And by doing so, since the numerator of the logarithm is x squared multiplied by y raised to the power 1 over 2, we have log x squared plus log y raised to the power 1 over 2 minus log z raised to the power 4 over 3. And through the law of logarithm and by simplification, we take down the power of their respective powers, and we have our final answer to be 2 log x plus 1 over 2 log y minus 4 over 3 log z. So we'll move to the next question quickly. So when you have ln 1, natural log of 1 is equals to 0, and natural log of e is equals to 1. So if natural log of e is equals to 1, what would be natural log of e raised to the power of 5? Now, it is very essential to know that since we have e raised to the power of 5, and we apply the law of logarithm by bringing down 5, and natural log of e is 1. So this means that the natural log of e is 1, then our final answer would therefore be 5 as well. So you can represent logarithm in form of natural log as well. Some people call it the Napierian logarithm. So we have another example. Now when you have e raised to the power of the natural log of 7, now it is known that the base of a natural log is always to the base of e, so you should have that at the back of your mind. So even if the base is not written out as e, you should have it at the back of your mind that the base of a natural log is always e. Now since e is raised to the power of natural log of e, through the application of laws of logarithm, the answer for the first part is equals to 7. So the answer is always the power of the given logarithm. Second question is e raised to the power 3 ln x. Now we have e raised to the power 3 ln x. So what we are going to do is we take back the base, the coefficient of the power of the logarithm. So we have it to be e raised to the power ln sq, and definitely our answer is still the same thing as s raised to the power 3. And the last one, now since 2, for the last question, since 2 is a coefficient and it is separate from the exponent of e, from the value of e, it simply means that we'll be dealing with e separately, and by dealing with e separately, we have to take back the power of the coefficient of the log, which is 4, as a power of y. So we have it to be e raised to the power ln y raised to the power 4. And since you know that e and ln will definitely cancel out, we have our final answer to be 2y raised to the power of 4. So our next question is log base of 2 x plus 5 equals to 3, and this is an equation of logarithm. And what we do is that the 2 take up the 3 as a power, and we have 2 raised to the power 3, which is equals to 8, and automatically the logarithm cancels out, and we are left with x plus 5 equals to 8. And by taking like terms, the answer for x is equals to 3. Now you can as well confirm and check for the value of answer by inserting back the value of x into the logarithm to prove whether the answer for x is correct. So quickly, we have another example: 5 raised to the power of log of 5 y raised to the power of 8. So since this time around we are not using natural logarithm. Now the reason why we are not using natural logarithm is because we have the base of the logarithm is the same as the power of the logarithm. So you see 5 raised to the power of log base of 5. So that's the only condition it can cancel out. Do you get it now? But if it is a different base, it can never cancel out. So similarly, for the second question, you can see that it is having base 3. So our answer is still x squared plus 6. So we have another example: log 2x minus 3 base of 3 equals to 2. So through our application, we have the 3 will take up the 2 as a power. So we have this to be 3 raised to the power of 2 equals to 2x minus 3. And by collecting like terms, the value of x is equals to 6. And you can confirm as well to see if the answer is correct by inserting the value of x into the initial question. So this is the last question for this video. We have log x minus 3 base of 2 plus log x minus 1 base of 2 equals to 3. So now, since you know addition in logarithm is still multiplication, so we multiply x minus 3 and x minus 1. Now when we multiply the 2, we have the expansion, or we have the expanded form to be x squared minus 4x minus 5. And as you can see, this is leading to a quadratic equation, and by solving quadratically, we have the value of x to be equals to 5 and x to be equals to minus 1, but you choose the positive part as your answer, which is equals to 5.